Okay, so we're looking at simultaneous linear equations, and we're looking at beyond your usual two variables, or usual for junior school. We're looking at more than that, so three or more variables. We're going to do the crunching as it were with technology. There are analytical methods for this, but this video precedes that. Okay, that will come later on. So what I'm just doing as I speak to you is writing in a system of three equations. Notice we have x, y, and z as variables, and we have unknowns there. So just writing those in. Hopefully you can ascertain the pattern there. Alright, and C3Z equals D3. So A, B, C, and D are coefficients, they're constants, and X, Y, and Z are variables. Okay. Now we can write that in matrix form. So we can look at a matrix of coefficients, A1, B1, C1, A2, B2, C2, and A3, B3, C3. We also have our column matrix of the variables x, y, and z. And we have our solutions matrix D1, D2, and D3. So that's the equivalent set of system of equations in matrix form. If you did the multiplication, you would get what's written there in black font, black ink. What we have, if we give them some label, is A times X equals B, which we might have seen that sort of matrix algebra, that little sort of matrix equation in the 2x2 videos we've seen before. Now, if there is an inverse to A, so given that there is an inverse to A, we can pre-multiply by A inverse, and if we have our A times X, I'm just going to put some arbitrary brackets around them. We would have to pre-multiply this side by A inverse, and that would come out as so. If we associate our matrices differently, we would have A inverse by A by X, it equals the same right hand side, which, as we know, if the inverse exists, we get then the identity matrix. So I times X equals A inverse by B. This should be familiar if you've seen our work previously on 2x2s. Okay, so the multiplicative identity there, we get X equals A inverse times B as such. I is a 3x3 matrix, so you know it's I3. So it's identity matrix. They're always square, aren't they? Right, so if A inverse exists, we have a unique solution to the system of simultaneous equations, and that unique solution is X is a solution. X is achieved by going A inverse times matrix B. Again, there's some very close parallels to what we've been doing previously with 2x2 matrices. So the general process is the same. So this is just a refresher in a sense. Now the technology bit that was in the title is related to the A inverse. Okay, the A inverse for 3x3 matrices is basically more involved. My screen is running away. Whoa, stop there. What are you doing? It just had a mind of its own there. Okay. Alright, I've got my screen back. Yeah, so the A inverse part with matrices of order bigger than 2x2 is done with the calculator at this stage. Okay, using technology, or typically a graphics calculator. Okay. Not the only technology by any means, but it's the one you're likely to use in the class most often. Let's look at an example. So we've got these system of equation here, 3 variables. So we need to put it in matrix form, and matrix A will be the coefficient matrix. So we've got 2, 1, 1 for the first equation you can see there. Now 0, 0x, right? 0, 3, 4, 6, be careful, 0 for y, 6, 0, 1. Okay, and then we have our x, which is the solution, will be the solution. It's our values for x, y, and z, so we put in our 3 variables, because that's what a solution is finding the value of the variables for this particular system of equations, a unique solution. And the answers to each. Okay, so we've got b, that's what they're equal to. So to justify your steps, just like last time, we're just going to write this in just a bit quicker this time. So pre-multiplying by, make sure you write this in, pre-multiply, and then we've got ix and x is A inverse by B. Now remember, the A inverse part is the bit the calculator does for you at this stage in our course. Okay, I've just paused the video and then I've just used my graphics calculator to work out A inverse. Previous video, remember, goes through the functionality of how to do this. So timesing A inverse by B, you get 1, negative 5, 2, according to the TI Inspire I'm using. Now, what does this mean? One interpretation, a geometric interpretation, is that we have 3 planes intersecting at a point, and each of them is represented by the equations above. So, because there are x, y, and z, we're not talking lines, we're talking planes. Okay, and what we got is a unique solution. So that's one of the 3 outcomes. We have a unique solution is one of them, and that's where we have 3 planes intersecting at a point. So there can be no solution, and the next scenario is there's infinitely many solutions. Infinitely many solutions. So we're not talking about lines, you know, they're linear equations, because they've got 3 variables. So we're talking about planes, and we can't really go beyond that at this stage because we haven't learnt enough other mathematics, but we will one day, and that's something further developed in future study. Okay, so to be continued one day in further units. So we can take it past 3 by 3. So in general, we have a system such that we have this going on. We'd have a system of equations like this, and that's a general look at it. And by the way, the A, B, C, D have been replaced by, there's no good using that because it's a general one. So we've replaced the coefficients A, B, C, D with something a bit more numerical. So you can see the subscript system for the coefficients there, and that translates nicely to matrices. So matrix such that we've got coefficient matrix, and so on. And we've got n by n, so it's not m by n, is it? Alright, it's not m by n, it's n by n, because we're talking square. Okay, we have to talk square matrices from our work. So n1, n2, and up to nn. Okay, so don't get confused. I know we've been talking about m by n previously, but as you know from our work, we've got to be talking square matrices. Okay, and we've got x1, x2 to xn equals I know D was used last time, B's being used this time. It's just a symbol, so don't panic. Because we're using A's here on the left hand side, we're just using the next letter of the alphabet here. Okay. So in conclusion, if this n by n matrix has an inverse, the solution of simultaneous equations has a unique solution. The system of simultaneous equations will then have a unique solution.